Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are going to discuss about the chapter Air, Wind and Cyclones. In this session we are going to see about air and its properties. Okay, let us see first the introduction part of this. We know that when we ride on a bicycle in the direction of the wind, it is easy to ride the bicycle, isn't it? But when we go the opposite to the direction of the wind, it is very hard and we may tire easily. Have you ever experienced this? Of course, you might have. When you ride a cycle in the direction of the wind, so the wind supports the cycling and we move very easily. The cycle moves very easily, isn't it? But when we go the opposite direction to the wind pushes us back. So the riding of bicycle becomes very hard and we may get tired easily, isn't it? Sometimes the wind is cold and sometimes it is pleasant and nice. Isn't it? Wind may be sometimes very cold and sometimes it will be very pleasant and nice. Wind can blow clouds and sometimes rise dust also. Have you seen this? Yes, sometimes clouds will be moving in the sky. That is because of the wind. And sometimes we may see on the streets rising dust into the air. That is also because of the winds only. Wind is sometimes gentle, but it can be really strong too and blow away the things also. Have you observed this also? Yes, you might have. Sometimes the wind will be very gentle, but sometimes it will be very strong too, and it uproots the trees and it blows away the things like hearts and this all, isn't it? And you have read in class 6 that clouds drive faster on the windy day. Why? Because these winds take away the water present in the clouds. Water droplets present in the clouds will be blown away along with the wind. So the clouds will be dried faster. So these all are because of the wind. Since wind has so much effect on our lives like this, we have to find out what winds are exactly. What is meant by wind? Let us hear what is wind here. The air around us is rarely still. Yes, air won't be found in still position for many times. It is found in still position very rarely. It will be always moving from one place to another places. So air moves continuously from one direction to another direction. It won't be in the still position for longer time. Very rarely it is found in the still position. But most of the times air will be moving from one place to another places continuously. It moves in all the directions. The movement of air is in many directions. This is what we call winds. So we know that wind is moving air. So we can say now the moving air is called wind. So the movement of air will be in all the directions. Air moves up and it comes down. It moves in all the directions. So this moving air is called wind. Let us try to understand something more about air and these winds. Okay. First, let us see where do we find this air? Have you seen our air? No, we cannot see the air because air has no color. That's why we are not able to see the air, but we can find it by its certain properties. Let us see what are those properties of this air. First, let us do a simple experiment here. Let us try to take a bucket full of water and a transparent glass. Now take a paper, crumble it into a ball and push it into the bottle bottom of the glass. See, she is doing here. She has taken a paper and she crumbled it, and she keeping this paper at the to the bottom of the glass, transparent glass. Now we have to invert this glass and immerse it into a bucket of water. So we have taken a bucket full of water, and the glass which is containing this crumbled paper inside is immersed into this bucket of water by inverting it. So first glass is inverted, and it is pushed or immersed into the water which is in the bucket. Keep the glass straight and press it so that the glass is completely under the water. So what we have to do? We have to invert the glass and we have to keep this in the straight position. Now we have to press this glass until it is completely under the water. Now let us take out the glass in the same direction without bending it. Let us take the glass out straight. And if we observe what happens inside the glass, if you take out the that crumbled paper ball and if you observe it, it won't get wet. It will be still dry only. It won't be wet even after inserting into the water. Why? What happened inside? Even though we kept this glass into the water, we immersed this glass into the water, the paper inside the glass won't be wet. Why? Because water does not enter into the glass even though we immerse this glass into the water. Because inside the water, this transparent glass, there is air. Air won't let the water enter into the glass because this place in the glass is already occupied by air. This proves that air occupies space. Okay, that is why only water could not enter into the glass, and hence that paper or the crumbled paper ball is still dry. Okay, this proves that air occupies space. Now let us see another experiment to prove the same. Fill a bucket with water. Take a bottle with a narrow mouth and immerse it in the bucket till it fills with the water. See, this is happening here. You have taken a bucket of water and you have taken a bottle narrow neck, narrow mouth, and you have immersed this bottle into the bucket of water and till the bottle is completely filled with water. What do we observe while filling this bottle with water? What do we observe? We observe that air bubbles come out of the bottle when water entered into it. Have you ever done this experiment? We too can try this. Take a empty plastic bottle and immerse that plastic bottle into the full of water where it is present in the either kind of like a bucket. Then we observe water enters into the bottle. At the same time, we observe bubbles coming out of the water bottle. These bubbles because of the air present in the bottle. When you push this bottle into the water, the air present in the bottle comes out. Then only water enters into that bottle. So from this also we can say air occupies a space. When this air comes out only water can enter into that bottle. Okay, from this we can say that a glass or bottle that we think is empty is actually full of air. So we are telling in this experiment we have taken an empty bottle, but actually we are telling it is empty, but actually it contains air in it. It is full of air. So those bottles are a glass which we say as empty, they are not actually empty. They are containing air in it. That air occupies space. That is why only in the previous experiment that crumbled paper won't get wet because that air present in that bottle or glass is not allowing that water to enter inside. And here also bottle is filled when the air escapes out from that. Then only water is entered into the bottle and it is filled with the water. Okay. From these two activities, we can say that air is everywhere. Any bottle, glass, or any other container that appears empty is actually full of air. Nothing can be added into it unless the air inside the bottle or glass is removed. Then only after removing that air from the bottle or glass only anything can be entered. It is only when some air is removed that something else can be entered. So we have seen in the previous case when we immerse the bottle into the bucket of water, air bubbles out then only water enters into it. If you keep the glass inverted and if you immerse into the water, water cannot enter into the bottle. Why? Because already that place in the glass is occupied by air. So when you tilt the glass, then immediately water enters into the glass. What is happening while tilting? The air present in the glass will escape out. So when air is removed, then water enters into the glass. So from this we can say it is only when some air is removed from those containers, then only something else can enter into that container. See here, an inverted bottle is immersed into the water. Even though it is completely immersed into the water, water cannot enter into this because the place in this bottle is completely filled with air. Already there is air in this. So it won't allow the water to come inside. When you tilt this, when you tilt the bottle, then what happens? The air present in this bottle will go out in the form of bubbles. We can see bubbles coming out from the bottle. Then only water can enter into this. So from these all experiments, we can come to a conclusion that air occupies a space and the bottles or containers which we feel empty are exactly not empty. They are filled with air. Okay. Now we can say air occupies the space around us. So if you see around us where you feel it is empty place that is actually filled of air. Now let us see another experiment to prove that air exerts pressure. Okay. Not only occupying the space, air also can exert pressure. You know that a bicycle tube or tube of any other vehicle can burst when it is overfilled with air, isn't it? Yes, the tubes of the cycles or other vehicles may burst when they are filled with excess of air. How does it happen? What does the excess of air do the tube? It is making the tubes burst because air exerting pressure on those tubes. By exhibiting more pressure, those tubes will be bursted. So let us try to discuss about this. How the air in the vehicle tubes keeps them in shape. Let us see here some examples. Take a balloon and fill it with air. Keep blowing more and more air into it. What would eventually happen? What happens when you start blowing a balloon? Its size will be bulged. We observe that. When you keep on blowing the balloon with the air, what happens? The balloon expands and after a point it bursts, isn't it? If you blow continuously air into a balloon, it bulges and it continues to bulge. At certain point, it bursts because the air blown into the balloon it exerts pressure on the walls of the balloon. That balloon can withstand the pressure to a certain extent. If continuously it is expanded, at certain point it cannot control that pressure and immediately it bursts. This is because of the pressure exerted by that air inside the balloon. Let us see some other situations where air exerts pressure. Okay, let us see some more. For example, these may include those where air exerting pressure. One is a balloon being filled with air. The air filled football that becomes harder. In these all cases, we can find air exerting pressure, isn't it? A balloon being filled with the air. What happens then? The balloon comes into a certain shape. That is because the air filled into the balloon will exert a certain pressure on the balloon and it bulges and it gets certain shape. Not only that, the air filled into the football and that becomes harder, isn't it? The football or some other basketball they become harder because they are filled with the air and the air present in those will exert pressure on the walls of the football or on something ball so that they become harder. Okay, and water rising through the hand pump. Have you ever seen a hand pump? When you pump it, the water coming out water rising out from the pump there. This is because the air inside the pump exerts certain pressure, and hence it raises the water through the pump. And even the tubes of the cycle, scooter, or a car, they become harder when we pump air into those tubes, because the air sent into those tubes exerts pressure on the walls of the tube inside, and hence they become harder. Okay, these all are the what do you can say situations where air exerting pressure. Okay, now let us see some other example. Take a syringe and draw out its plunger to its limit. Say this is a syringe they have taken. We have to pull out this plunger till its limit. Now let us close the nozzle of the syringe with a finger tightly, and then if you press the piston into the syringe, what do we observe? The piston will not go into the syringe even though you press harder. Why? Because inside the syringe there is air, and we have closed the outlet of this air so that air is being inside the syringe only. Now if you press this nozzle or piston, this air exerts pressure on the inner wall of this piston. That's why this syringe will not enter inside. This piston will not enter into the syringe because the air present in this syringe will exert pressure on this nozzle. That's why it is not entering inside. Okay, this also proves air exerts pressure and occupies space. Okay, now let us see some another property of air, that is air expands on heating. Let us try to prove this also with some experiments. Take an empty injection bottle and one empty ballpoint refill. Okay, remove the pin of the refill and insert one of its ends in the cork of the injection bottle as shown. So what they have done, they have taken an injection bottle and an empty refill, ballpoint pen refill. Now its ballpoint is removed and it is inserted into the cork of this injection bottle from one end. Okay, now put a water drop on the upper end of the refill. See, they kept a water bottle on the upper end of this refill. Now rub your hands together so that they become warm. So if you palm your hands, if you rub your palms fastly, they become warm. Now carefully pick up the bottle and hold it in both of your hands for some time so that bottle also becomes warm. So if you rub your palms or hands, they become warm. Now with these warm hands, hold this bottle into your hands so that that bottle or syringe injection bottle also becomes warm. So if the injection bottle becomes warm, what happens? So when it becomes warm, we observe that the water droplet on the ballpoint refill inflates when the injection bottle is held in our cupped hands. So when you hold this injection bottle in your cupped hands which are warm, then what happens? The air inside the injection bottle also becomes warm. So when it becomes warm, immediately it starts expanding. So it will try to move away through this ballpoint refill. Then there is a water droplet on this other end of this ballpoint refill. Then this air bulged inside will push this ball drop out, so it bulges. Okay, it inflates. This is because of the expansion of air inside that injection bottle. That is because of the warmthness. When it become hot, air expands. We can infer from this observation that air expands on heating. At the same time, we can also say air contracts on cooling. For that also, we can do with the same equipment one more experiment. That is, now keep this bottle in a saucer of cold water and observe what happens to the drop. The inflated water droplet again contracts, size will be decreased, and it comes a little flow into the ballpoint refill. This is because the air inside the injection bottle will be contracted when it is cooled. Okay, we can state that air in the bottle contracts when it is cooled by keeping the bottle in the cool water. Okay, from this we can say the hot water, the air becomes expanded when it is heated, and air contracts on cooling. This is one more property of air. Now let us see one more experiment which proves another property of air, that is hot air is lighter than cold air. So let us see how to prove this. Take a two paper bags or empty paper cups of the same size. Take a broomstick and hang the two bags in the inverted position on the two ends of the broomstick. See how it is shown. Tie a piece of thread at the middle of the stick. Hold the stick by the thread like a balance, weighing balance. Now if you observe, as these two paper cups are of same size, then it will be maintained at the balanced position. What you have done here, you have taken two empty paper cups and you have tied these two to a broomstick at the two edges by using thread. And to the same broomstick, you have tied a thread at the middle. Now we are holding this broomstick entire equipment with the thread at the middle. Now it seems like a balance, and these will be at the same height because both the paper cups are made up of the same paper and same size also. So they weigh same weight, and hence it will be in the parallel position. Now put a burning candle below one of the bags as shown in the figure here, and observe what happens. What happens when you keep a burning candle at the below of one of the paper cups? So because of this burning candle, the air present in the cup becomes warm, hotter. So we observe that the balance of the bags disturbed, and the paper bag on the candle side moves up because the air in the paper cup becomes hotter and lighter in the weight, and hence it moves up, and the other side cup will come down because the air in the paper cup which is at the candle side becomes hotter. The hotter air will be lighter in weight, and hence the cup moves up. Okay, this proves hotter air is lighter in weight than the cool air. We have to note one point here, that is we have to use paper bags or cups as they are of lightweight, and it would be easier to see the results of this experiment if we take any such light objects to hang on the thread. Yes, we have to take the lightweight paper cups, then only we can see the effective experiment result in this. If we take heavyweight paper cups or heavyweight cups, we cannot see the results accurately in this experiment. Okay, and one more point you have to observe carefully here, that is you have to handle the burning candle very carefully as it is having burning, so it may catch fire easily. These paper cups, you have to be very carefully while doing this experiment. Okay, from this experiment we can prove that hot air is lighter in weight than the cool air. Okay, so these are the properties of the air. What are those? Let us recollect once. Air moves in all directions. That moving air is called wind, and air occupies space. The bottles, glasses, which we observe as empty, actually they are filled with air inside. So air is in all the places surrounding us. And one more property, air exerts pressure. We have so many observations in our daily life because of this exertion of pressure by air. And one more property of air is hot air is lighter than cool air. Okay, this we can say as properties of air. Thank you for watching our video. Please subscribe our YouTube channel Aims Today and visit our website aimstoday.in for latest updates on recorded videos.